We're going to go ahead and take a look at where data is coming from and problems that occur with some data. Now we have observational studies and we have experiments. In an observational study, you're attempting to basically record information without influencing the results. However, with an experiment, you're deliberately trying to impose a treatment and therefore influence the results, and then you are recording the results. With an observational study, you can make observations about something, but you cannot actually prove anything. With an experiment, you're more likely to be able to prove something, saying that this certain treatment works better than this other one, because you controlled for different factors and it was specifically designed to try to look for something. Observational studies, though, are important because it gives us opinions about voters or insights into different behaviors or insights into different reasons why things are linked. However, we can't actually prove anything with an observational study. Now, when we're dealing with experiments in observational studies, it's common to have a confounding variable. Confounding variables we talked about before are once again explanatory variables or lurking variables that affect our response, but we cannot separate those variables from everything else. So suppose you're considering good grades in a test. Is good grades come strictly from studying? No, because there's some natural ability, intelligence that we are all given. Is it basically all given on intelligence? No, because somebody can study a lot. So studying and intelligence are confounding when you are looking at getting a good grade on a test. Now, researchers want to answer questions about large groups of people. Those large groups of people we end up calling the population. Could be all the women in America, or could be all the men in Minnesota, or something along that lines. However, a smaller group of people is for the most part what you're going to go ahead and collect data on or look at, because for the most part it's not practical to go ahead and take a look at the whole population. So you work with a small subgroup, and that we call a sample. Now, once again, your population is everybody that you're looking at, where your sample is a small group of that overall population. Now, you might be considering all humans or all crickets or all working age people in California, where a sample would only be looking at maybe 20 to 40 of those people or crickets. Now, a parameter is a number that describes your population. So it could be the mean of all the humans, or it could be the average weight of all the crickets, or it could be the average age of all the working age people in California. That would be a parameter. If you have a number that's describing something you got from your sample, we consider that a statistic. Well, we want to go ahead and collect our data. But there's good ways to collect your data and there's bad ways to collect your data. For the most part, you want to go ahead and have a large varied population sample, or a sample that's large and varied, representing your whole population. But that's not necessarily easy to do. Some bad sampling methods are the convenient sampling. In other words, you just ask whoever's around. It's the man on the street survey. TV journalism is often using that. For the most part, they're trying to get a reaction, and so it may be an emotional question, but they are pretty cheap and they're easy to do. However, when you're dealing with man on the street surveys, you can get totally different results depending upon where you are. If you are outside a small town in Idaho versus on the streets of Berkeley, California, you would get two totally different answers about gun control and legalizing marijuana from each one of those groups. So in other words, you end up getting a skewed result. That skewed result is considered a bias. Voluntary samples are often bad because for the most part, if somebody has the option to choose to respond to a sample or survey or not to respond, well, for the most part, people are going to choose not to respond unless they have a strong feeling one way or the other. If they have a strong feeling one way or the other, then they're going to go ahead and let you know their thoughts. Otherwise, they're not going to go ahead and take the time. So you're really only getting the two extremes of the possibilities out there. And so you get a biased um, sample. Now, here's an example. There was a questionnaire sent out to 100,000 women. Only 4.5% responded. And this person was using it to collect information for her book. Well, you have a very low response rate. And since it's voluntary, only the people that are really for or against the love, sex, and relationships, have a strong opinion about it, are going to go ahead and respond. Now, in this book, then, since she only used the response of those few people, she ended up seeing that the women were fed up with men and wanted to fight with them, or that the anger became the theme of the book, which is not really representative of all women in society. It was only representative of those 4.5% of our 100,000 that responded. Now, you see online surveys a lot. Once again, they are voluntary. They'll often have a little disclaimer at the bottom saying it's not scientific and reflects only the opinions of those who responded. Now, a probability or random sampling is a good sampling method. We want to try to do a random sampling when we are looking for our subjects, for our sample. When you're dealing with a random sample, it eliminates the bias or tries to reduce the bias. Now, there's different ways to do random sampling. One of them is a simple random sample. In other words, you would just assign everybody in your population a number. And then you would go ahead and use a computer or a calculator to generate random numbers, and you would select those individuals that were assigned to those numbers. There's also a random number table in the back of your book that you could go ahead and use if you wanted to do it by hand. Now, this right here tells you how to go about using your calculator to do random numbers. There's also a random number applet that you can go ahead and use. So suppose I wanted to go ahead and get a sample of 10 from the popular numbers 1 to 100. I go ahead and sample this. It's randomly choosing 10 numbers from the numbers 1 to 100, and here we go. You can also have your calculator do that, and we'll go ahead and walk you through that here. To go ahead and have your calculator generate random numbers, you want to hit Math, arrow to the prob, and then you want to arrow down to rand int. Now, if I wanted to generate numbers between 1 and 100, I'd go 1, 100. If I wanted to go ahead and generate 5 of those numbers, I would hit then comma 5 and then hit enter. And now my calculator randomly chose 5 numbers between 1 and 100. Hopefully your calculator ended up getting different numbers since it's supposed to be random. We also have stratified random samples. In other words, you're breaking your overall population into a few smaller subgroups, and then you're choosing a simple random sample from each one of those smaller subgroups. So here's an example. Your population is the University of California Irvine students, and you divide them into male and female. And you would select a simple random sample of males and a simple random sample of females. Or you could go ahead and divide the population by major ethnic groups. Or you could divide the counties in America into either urban or rural, and then go ahead and choose a simple random sample on each one of those. Now, your simple random samples, when you're dealing with a stratified sample, do not need to be the same. So when you're dealing with the University of California Irvine students, you could choose 100 males and 150 females. They don't have to be the same size. We also have a multi-stage sample. And basically, it's just doing your stratified random sample that we were just looking at, but you're repeating that. You're taking and dividing it into subgroups. Each one of those subgroups, you're dividing it down farther yet. So you could divide your areas into rural and urban. And then within each one of those, you could look at the ethnic groups in the rurals and the urbans. And then you could go ahead and divide or choose a simple random sample from each one of those ethnic groups within each one of the rural or urban areas. So if you're repeatedly breaking it into smaller and smaller subgroups, you're dealing with a multi-stage stratification. Now, when you are looking at your survey results, you want to be aware of the non-response or response bias or how wording affects stuff. Now, sometimes people have something to hide, and so they don't want to answer because they don't want to get in trouble. Or it is possible you're asking about something that's questionable, like how much do you really drink? Well, a lot of times people aren't going to be extremely honest in how much they drink, especially if they end up drinking a lot. Or if you ask men how many dates are you on a week, you might get a different answer than in reality. Now, the way you phrase a question can also affect your response. So, consider this one here. Do you support a woman's right to have control over her own body at any time during the pregnancy, even during the last trimester? Here, we have this in the background, and now we have this question. Partial birth abortions. The abortionist induces the mother to give or to start the birth process until the abortionist gains access to the head of the child. He then or she sticks an instrument into the child's skull, sucks out the child's brain, killing the child, and then the abortionist delivers the rest of the dead baby and disposes of the baby by throwing it into the trash. Do you support this hideous murder of unborn children through the practice of partial birth abortions? Now, this question and this last question are really asking the same thing. However, you're going to get totally different responses from each question just because of the way it's phrased. Now, this slide here I just came across and I thought it was cute, and so it got thrown in here. You also want to be careful of undercoverage. Some people are going to try to hide. They don't want to be noticed, and so just be aware of that. And then we also have response bias that we talked about a little bit ago. If you're dealing with drugs, you may not give a certain answer, or if the interviewer is a police officer, you're definitely going to give a different answer than if it was just somebody dressed in normal clothes. And that would be an interviewer bias.